This one is one-time programmable. Is it not an erasable? One-time programmable read-only. Uh-oh. Is the other, are these all one-time programmable? This is an, oh, this is not an EEPROM. Oh, it's just an EEPROM. Oh. Erasable, stay away from OTP. Oh, now I get what you say with OTP, one-time programmable. Yeah, I mean, of course, I would want to stay away from OTP. Now, lessons learned. Okay, what a waste. I don't want to look up how expensive these were. They were probably a couple of euros each. I'm an idiot. It's so cold. It's so cold today. In Germany, it's so cold. Our heater broke and now it's so cold. It's so cold. I need to keep you warm, Mr. Dog. I need to keep you warm. It's so cold. It's so cold. Here, let me warm you. Let me warm you. It's so cold. Just kidding, of course. It's damn hot today. It's so hot. It's so hot. Ah, the pants. I need to get the pants off. That's here, TOS. TOS. All right, we safe. We safe. We safe. Ugh. How's everybody doing? Welcome back to the stream. So today, a bit earlier in the day, let's see how it goes. It's extremely It's extremely warm today outside. In here it's actually okay. I have the AC on. It's fine. But outside we have right now like 37 degrees Celsius, which is a lot for Germany. You're sitting outside dehydrating. Why are you not drinking? That's a big mistake you do there. Today I released my latest video. Again, it's another episode of the browser exploitation series. I hope you all watched it because these videos perform terribly, which is to expect. It's very technical videos. My channel has grown past the technical, the deep technical crowd. So of course it's a very limited audience that will watch these right now, but I'm very proud of them. They create a nice backlog. I feel like they make Live Overflow whole, and I definitely want to keep making these kind of technical videos and these kind of series once in a while, because while they don't appease to the masses, I hope at least that they are deeply meaningful to a few people that get really like motivated through them, or discover a new topic that they didn't know they like. Yeah, I hope you check them out. From the statistics, again, the latest video is the worst performing video out of the last 10, which means a lot because 6, I guess, of these last 10 were, or 6 were also like technical. So yeah, fun times on YouTube. But yeah, I mean, not complaining about YouTube here. It's just normal. That's also, of course, why I created Live Overflow 2, the second YouTube channel, where I upload all the stream highlights and all the other stuff, because on there I can be clickbaity. I thought about changing my slogan on like YouTube and Twitter is like wannabe hacker. So on Live Overflow 2, I think I want to change it to wannabe clickbaiter or something like this. I'm really practicing on there right now. How's the weather in the UK right now? Are you also dying, or you are in the UK, right? All right. So plans for today. We just continue building. Today we have a bit more time, so I expect it to be a bit longer stream. Yesterday we kept the stream fairly short because I definitely wanted to host Zoding, because he often hosts me, and because I stream always later than him, he always hosts me, so I never get the chance to host him. So yesterday I streamed earlier, we had to keep a fairly short stream so to be able to host him. And then like 10 minutes or 15 minutes or so into the after we host him, his internet broke and he canceled the stream for the day. Amazing. Good job with it there. Please don't stream, I need to learn. That's amazing, because these streams are extremely boring. I don't understand why you wouldn't want to learn. What is counting YouTube subs Twitter for in the background? Yes, I do get this a lot. This is the overpriced La metric. You might recognize this from a lot of other YouTubers. So I believe if you type into Google YouTuber counter background or something like that, I'm sure somebody you will get that answer too. And yes, you of course are also surprised by the price of $200, like everybody else who keeps asking about this thing. Oh man. Should I tell you, as the dozens of times before, it wasn't that much, why the price might still be justified? You know, it's not a mass consumer product. I believe it was a Kickstarter. You know, stuff just costs money if they are not mass consumer products. You slept right through that's awesome. I'm glad to help you sleep. I found a kind of a 40 euro thing on Amazon that kind of looks similar. It's like a 16 by 16 display, but it seems to have the similar concept of square pixels. I haven't bought that yet. I want to check that out and hack around with it some other time. I can't even read the number. Yeah, because it's out of focus, of course. Put that into focus and then it's fine. But yeah. I mean, of course it's here to brag right now, but usually it's just, you know, it's you know, why am I doing YouTube videos and Twitter? Of course, I only care about those numbers going up. So it's important that I've displayed them across the apartment everywhere, in every room, so I can see them even in the bathroom to see that number going up. You know, that's what I live for. Okay. Anything else? No, I think that's it for now. You don't have Alexa announce them vocally every 10 minutes. Oh, you give me ideas. Good job. I like the way you think. Yeah, it's an amazing idea. Somebody has to write an app for that. Jamie, get on that as a feature for Notify Me. Make it announce the everything, the numbers. Yeah. Okay, so where are we at? Let me switch to the overview camera for a moment here. So if you haven't been here the past two streams, Milo, you will see that we made quite some progress. We have finished the RAM module and we have built the instruction register yesterday. So this is this here. And then we watched a couple of videos on how to implement a counter with how counters in binary can be created with a so-called JK flip-flop, and then Ben Eder explored this JK flip-flop and the master-slave JK flip-flop, and so yeah, we watched that yesterday, and I believe we now continue with building that program counter. I think the next video in the series is program counter build. That is literally the next video. Yeah, client bottle +1. Buy your own on clientbottles.com, I believe. And is that a lollipop on the client bottle? Yes, it's a lollipop that is supposed to be my red. You know, it's supposed to be Live Overflow. The Live Overflow logo has like a red recording circle at the start, then comes live, and then overflow. So you have the red lollipop, the live, and then the water overflowing. You know, actually these lollipops, let me put like add-on. Here are these lollipops. I have like a whole thing and I have not eaten one of them ever. But actually they are merchandise from, what is the company that this is merchandise from? Are you ready? Wire. They have offices here in Berlin. They sometimes do like presentations, and I gave a presentation there like almost a year ago or so, and I got a couple of those as merchandise. Okay, yeah, let's head into the video. Let's not procrastinate too much longer. Here's the schematic, pretty basic build. So we need the 245 and the 161. The 161 and the 245. There we go. we also still got the LEDs here. What else do we need? What he uses. Why is he using resistors on these LEDs now? Now, this gets a little bit crowded with the LEDs there. I wonder, does he build anything next to it? Oh, this picture. Oh no, this picture is different. I was kind of building based on this picture here. Is that the program? Oh, and this original build. Interesting. So he changed kind of how his build looks like on his original. So he made this build before he made the series, and here the program counter still is directly below the clock, while later he puts it over here. So this is, yeah, so he rebuilds it for the videos, I guess, and decided to change a little bit the arrangement. Making the counter, well, the chip that we are using, this is a specific chip that already implements the counting. In itself, that already is a little bit, it's not complicated, it's still pretty basic, but it is obviously, it contains a bit more components to make a count, to implement a counter. So this counter chip is obviously a bit the magic here. None of these modules have address decoding in it yet, so there will be probably a bit more going. I'm not quite sure what you mean with that. They don't have to. Do they need the address decoding in there? Do you mean the instruction decoding? The instruction decoder? The control logic that handles instructions? Do you mean that? How do the jump instructions know when it should load the value, or when do register A know it should read? Yeah, so that you mean the instruction decoder. That is done, as far as I understand, by the control logic, which is another board that will basically, down here we have the instruction register, and based on that value it will walk through the control logic, and that control logic then basically accesses all these yellow wires here. All these yellow wires are control inputs that enable or disable certain modules, and this will, so later we have this control module that I believe just goes to all these yellow wires, and as far as I understand, this control logic on when to enable what is kind of cleverly done with an EEPROM that he uses, kind of like a lookup table, in what state, for which instruction, in what stage to turn on and off what. I believe that's, I think, kind of my, like the glimpses I got about that. My current understanding is that, but I'm not 100% sure. When I was just clicking on Ben Eder's website around, I saw a video on how does this computer execute an instruction, or a similar title like that, which sounds like exactly, it walks through exactly how this decoder works and how the single modules are turned on and off. So I haven't watched it yet. I kind of also don't want to watch it already, but if you are really, really curious, that might be a good video to watch. How would you have 16-bit RAM on an 8-bit computer? Maybe you should rephrase your question, because I don't exactly. Here's another thing. I don't actually know why you call it an 8-bit computer or a 16-bit computer, because in some way this computer only uses 4-bit for memory. So it only has 4-bit memory. It uses only 4-bit for addresses, but it has an 8-bit bus. So I guess the definition is based on the bus. And so now is the question, how do you do an 16, in the same way we do 4-bit addresses on an 8-bit computer, is there a way how to do 16-bit addresses on an 8-bit computer? And yes, you make banks of RAM that you can switch with the register. So basically, for example, AVR, so the architecture of Arduino, they are 8-bit AVR. They only have 8-bit registers. But there are a couple of special registers. Also, the instruction register is, I believe, 16-bit. And so, for example, the X and Y register, they belong together. They are each 8-bit register, but they can also be interpreted together as a full 16-bit address. So it's an 8-bit AVR, but it actually can address 16-bit. So the idea of extending this to 16-bit right now would be that we have to make the control, the control circuit that handles the instruction a bit more complicated. Basically, we need then to have like 3-byte instructions, I guess. 1 byte for the opcode and then 2 bytes, which is the 16-bit for the addressing. So that makes it a bit more complicated. But then we could have like an address register. We make one 16-bit register, for example, that we can call the address register or pointer register or so. And then we hook that up to the RAM. And so every time something wants to act on the memory, it first has to load that address into that 16-bit register. For example, that's kind of how I imagine it right now. But like I said, I'm not sure about the feasibility, if that makes it somehow like extremely complex or it blows up in the terms of connections we need. And but yeah, that's something I'm keeping in mind, and I'm kind of looking forward to figure out if that's something feasible or not. Because 16 bits would be really cool. 8-bit, full 8-bit memory with 256 bytes is already cool. You can run a lot in that. But if you would have 16-bit, wow, you can get everything in there. But yeah, I'm not so sure if it's feasible. I'm also not sure if we necessarily need it. But 16-bit, you could really implement, for example, also a stack, and you have really enough memory to handle everything. Would it be able to boot Linux? I don't understand like this kind of low-level computing very well. I believe we would run into issues because Linux expects certain features of a computer. There was a really interesting talk. Is the PlayStation... Oh, God damn it. Is the PlayStation a PC? I believe was the talk. I believe in this talk, Mark Ken, or whatever his name is pronounced, I think explains what is a PC, like what are the requirements for a PC, and why the PlayStation fulfills it, and why the PlayStation can boot Linux. I believe this was this talk. The PS4 is why it's not the PC. Okay, I completely misremembered. Let's watch this for a second. I want to refresh my mind. I think this was super interesting.
Or anything. What's going on here? Okay, let's talk about hardware. What is x86? x86 is a mediocre instruction set architecture by Intel. It's okay, I guess. It's not great. It's okay. PS4 is definitely x86. It's x86-64. What is a PC? A PC is a horrible thing built upon piles and piles of legacy crap dating back to 1981. The PS4 is definitely not a PC. Then again, that's practically Sony level hardware fail, so it could be, but it's not. Okay, so what's going on? Well, a legacy PC basically has an 8259 programmable interrupt controller, 8253 programmable interval timer, a UART at IO3F8, which is the standard address for a serial port.
I think, if you break down PCs to that level, I think that adds just so much more understanding to what a computer is, because the hardware is so magical, stripped away from us nowadays. Realizing that, that there is defined at this address, so if you interact with the address 3F8 on an Intel CPU, then that is defined to be a UART, input and output, so a serial input and output controller. If you are on that low level, like ring 0 or whatever, and you write and read, you interact with 3F8, that is a serial port, like that is defined. Why is it that number? I have no damn clue, but why is it specifically that address? But that's the address.
It has a PS2 keyboard controller, 8042. It has an RTC, a real-time clock with the CMOS. Everyone knows the CMOS, right? MC146818 is the chip number for that. An ISA bus. Even if you think you don't have an ISA bus, your computer has an ISA bus inside the cell switch somewhere. And it has VGA. The PS4 doesn't have any of these things. So what do we do? Well, okay, let's look a little bit at how a PC works and how a PS4 works. This is a general, simple PC system. There's an APU or an Intel Core CPU with a South Bridge. Intel calls it PCH, AMD FCH. There's an interface that is basically PCIe, though Intel calls it DMI and AMD calls it UMI, whatever. DDR3 RAM and a bunch of peripherals and SATA, whatever. The PS4 kind of looks like that, right? So you'd think this can't be that. Yet, what's so hard about this?
Yeah, it's a really great talk. I really recommend it. I posted earlier the link in chat. It's called Team Fail Overflow Running Linux Portal 2 on Steam on PlayStation 4. I guess it's a console hacking talk 2016. Yeah, at the 33C3. You could probably hook up a UART terminal. That's actually a modification I'm really also strongly think about and want, because that would allow us to kind of interface with an Arduino or with something that can interface, or directly even UART with a computer, because it would be kind of cool to have like Twitch chat integration with that computer to be able to send some kind of input to the computer. I think it would be kind of cool to have like serial on there. You could hook up a character LCD. Yes, I actually bought a character LCD. That's another thing I want to. I don't know exactly how it works, how feasible it is. As with all these things, we can really plan and think about that once we fully understand and have the whole setup to understand what we would need to modify to make that stuff work. Once we have a better understanding how all the instructions and all that stuff works. But yeah, this is also definitely one thing that I'm. If you plan to integrate UART, will you implement interrupts or will you resort to polling? Again, all stuff that I'm thinking about, but I don't know yet because I don't understand this computer enough yet to make such a decision. I guess the idea of implementing some kind of interrupts would be really cool, but the question is, I mean, the reason why the architecture, the setup is the way it is here is because it was made kind of like Ben Eder made it so that it like works on the breadboard, right? Like a lot of the design decisions here are to make it work with LEDs on breadboards. And so I guess that somewhat limits us, because of course we could do whatever we want we do, but we are a little bit limited with the realistic limitations that we have, and yeah, does that make sense? So yes, of course, interrupts are one of these feature ideas that are very common to like microprocessors and computers. Interrupts are an extremely important part of those devices. So yes, it's definitely something that makes sense to think about, but how feasible it is, I don't know yet. UART is probably the easiest. Yeah, I wonder about that, because for UART, so if you speak directly your own UART, you obviously need to honor the speed of the UART, the baud rate, which would mean the computer would have to run, for example, at that baud rate, so that, for example, we can use the clock to help us push out or read in the bits. And that seems to be extremely difficult to get like the exact baud rate correct, and then it would only work on that baud rate. Then you could think, okay, we make a second circuit that only speaks that baud rate and kind of like interface those things together. That's another option. But what I'm more inclined to do, which I guess is a little bit of cheating, but maybe also not, then kind of make an input register where anything can just write 8 bits in there and the computer can react to it. May that be connected with some kind of interrupt system or just polling, I don't know, but let's say there's an input register, and then we can hook up to that 8-bit register whatever we want as inputs. And for example, we could then hook up an Arduino, and the Arduino does all the serial stuff and just also a bit of buffering or so, and then puts those bits into that input register for our computer. I see that as a more realistic approach, and also good enough for me. UART is serial, by the way. We are talking about serial. Will you use this computer to accelerate AES? No, not AES. We do hashing. It's an ASIC for blockchain. Okay, so the other chips we connect are also the middle ones there, starting at pin 3 and starting here at the second one. All right. But if you do kind of like democracy style Twitch plays Pokemon kind of rules to have always like a voting window of like 10 minutes or so where the chat can enter how many new wires should be added, and if enough people praise Helix. Oh, it was such a good time. Oh my gosh. One of these things, one of the good examples of where the internet just made something amazing happen. Yeah, actually, it's a much simpler language, something like Brainfuck would be probably easier to use as a compiler for this computer that we are building here, because it doesn't. Does Brainfuck have the concept of a stack? I completely forgot. It's a Turing machine, yes, I know, but the question is if it has a stack or not. There's no stack. Yeah, okay. Yeah, so that would be probably easier to implement on this computer here than like a compiler for C or so. Yeah, Brainfuck would be pretty easy. Only need data input instruction. Yeah, that makes sense. The data input instruction, yeah, so that would also kind of work with that idea of having that input register that I'm thinking about. Then that would kind of work. There's another ground connection. What is that? Is that the direction bit? The direction bit will be just also consistently put to ground. We did this to ground? No, that's not correct, is it? Oh wait, all of these we did the direction bit to VCC, but here we did it to ground. Why does this make sense? What does ground mean, and what direction will it then go? If this is 0, it will the inputs here are just coming in from the bus, so it's never has anything to do with. Wait, I feel like my head is like exploding. Why do I have such a hard time grasping this right now? Oh my gosh, I have a headache. Okay, wait. Let's think about this. This is more complicated than it appears. No, it feels more complicated than it should be. If the direction is set to high, how we have it done on all the other chips here, then, wait, I guess we can switch here to make that bigger for everybody. We never output to the bus, I just realized. We never output to the bus because the program counter will always connect directly to the instruction register, I believe. Right? No, that makes no sense. It will. Why do we only make this input? Why do we do the direction of the. So I have a hard time right now because. So we use this chip, the 245. I might need a short break or something. I need maybe fresh air. I'm like. I realize, do you know that feeling when you are drunk or when you get really tired where the most basic stuff appears, you understand in the moment that it's like basic, but your brain is not working and you need to like basically walk very slowly because you realize if you go too fast, your brain doesn't follow. This chip only outputs to the bus. The counter itself has the ability to read from the bus. Yeah, so it only has reading from the bus. This is what this is set to. I understand. What I have a bit trouble with why we put the other ones only to output. Because those registers also want to read from the bus. Yeah, of course the direction flag is to avoid a certain direction at certain times, but this is what I try to wrap my head around, because we tie the direction to a certain state. It can either only read or either only output. And all the registers here we have tied to only ever be able to output. Yes. While the program register we have always tied to ever only be able to input. Why is that? Because all of those registers read and write with the bus, of course. You get what I'm saying? I understand that it has to be able to read for jumps, but all the other registers can also read from the bus to load a value, to move a value into the registers. All the registers have to read and all the registers have to write. So I try to wrap my head around why for the registers we have tied this chip to always output, while we can still control if we do the output or not with the enable, but the direction is always fixed to this chip will always ever do output, while for the counter, for the program counter, which effectively is also just a fancy register, right? It just keeps counting up. Here it's only tied always to input. And so I try to wrap my head around the difference right now. It definitely has to do with the chips. That chip, I guess, I don't know. It's just reverse. Okay, so this is the most useful tip probably right now. It's just reverse because the output pins of the counter are on the other side in comparison to the flip-flops. That might make the most sense. Let's check that. Thank you, Feldy. That sounds like a good thing to check. I haven't thought about this. So Q is the output. All right. So the inputs are at the bottom, while all the other registers have its output at the bottom. Thank you, Feldy. Amazing. That explains it. Now it's consistent. Now they are all the registers are the same. The inputs and output were just bottom and thing replaced. Yeah, so I have a NAS where I have all the clips where I offload everything that I don't need right now anymore, but editing, of course, I want to edit from an SSD directly in the PC. Yeah, it's a free NAS. It's like one of these HP. It's quite old at this point. It's like one of these HP microcomputers or so that have like some slots for hard drives, and I have free NAS running on it. But I'm getting a bit lazy, and it's a bit annoying. And so I actually wanted to check out one of those ready solutions like Synology or QNAP, just because I don't want to really admin it. I'm annoyed by having to admin it and having to deal with it, and I just want like something that just works. You will believe me, I will be the last person to implement some weird, intriguing shut-off system and then to make that trigger when the police or somebody is in here. Like, okay, wait, for somebody else is there, yes. But if that is police and they see I have an intriguing shut-off system and I triggered that, I like that just screams trouble. I feel like that just seems like the worst idea ever. It's like trying to run from the police, basically. It's like, it's not something you do. It just creates more trouble. Like, it's not like I need to hide something, that data, right? If I'm hopefully live in a righteous state. So my hope is that when they come, they have a good reason for coming, and then they look at this, and then they don't find evidence because they came for good reasons, but I don't have anything, right? I didn't do anything. So they come for correct reasons, they do their job, they check it out, they don't find anything, done. But I feel like if I have intriguing shut-off systems that burn, that have like dead man switches or so, not only can they go off at the wrong time and I lose all my stuff, but yeah, I know. Oh, the LEDs. How could I forget the LEDs? Can you recommend a NAS? Not really. I don't have any clue. I'm just a filthy consumer. I have like an HP, these kind of HP box PCs that have like drive slots, and I've installed FreeNAS on it. I have had that now for many years, but I want a second one. I don't actually need necessarily a second one, but I want to try out one of the products like a Synology or QNAP and see. I don't know the usability of these things. I have no experience with it, so I'm just gonna try out that. I mean, I will report back, I guess, with my experience. Yeah, that's a good boy behind me. That's a good boy behind me. It's a good boy. A good boy. I put we call this the tower. It's just a bunch of foldable like guest mattresses basically. We call this the tower, and so he likes to lay on there sometimes. And so I put it there for the stream so that if he comes to the tower, that you would see him on stream. Do you plan to change your status as a freelancer? I mean, change it to what? Should I call myself a YouTuber instead, or I don't know. I'm very happy with the way how I'm working, but you know, you never know what the future brings, and I don't mind to, like, my alternative job would be I would probably try to look for like a developer job. Either I find a cool like security research position that is not just like doing service for a company. I don't think that I would like to do that as an while being employed, like service, like consulting as being employed. I'm not sure if I would like to do that. So either I find a cool research position, kind of like an internal research team. That would be one kind of job I would like to do, and the other kind of job would be just be a developer. But it would have to be a cool project, like something like Google, Facebook or so, or like one of those big ones, kind of become a developer for these kind of apps, or you know, parts of those apps. I think that would be kind of cool. Every time you use Windows, it just feels shitty and all the apps look crappy. You get used to it. Like I go through phases. I have phases where I use my Mac exclusively, then I have phases where I use like Linux, and then I have phases where I use Windows. Now more and more I start to drift for certain applications to use them on certain machines. And right now I'm in a kind of a Windows phase. Like I really like to use Windows the past few months. Okay, so we added the LEDs. Awesome. I think I will use this opportunity to quickly have a small break. I need to refill my Texas drink and go to the bathroom really quick as well. And then we are right back to, I guess, test the counter. We need to turn on the electricity and see if it's like counting. Okay, yeah, so see you in a minute. Be right back. Thanks, LiveP, for solving it. You saved us all from the sellout hacker. I know you struggled there a little bit. It took you a bit. There was a small mistake, but in the end, you came through. You got it. Good job. Good job. Okay, cool. I guess we can turn it on. Having a MacBook Air as my main machine significantly contributed to my productivity. Almost no games would run, so I had fun typing stuff in the terminal. The MacBook Air is such a great machine. It's so lightweight, and yes, you know, so it's not really a gaming thing anyway, but you can take it everywhere. You can just use it quickly to like throw open on the sofa and have a nice terminal. You still get like the good terminal experience from Mac. I like it too. MacBook Air was my first MacBook. That's what got me into Mac. I had the 11-inch, the small MacBook. I loved that thing. My gosh, that thing was amazing. Thanks for the words. Thanks for the thanks for the tier 1 sub. My gosh, Brimco. Thanks. Okay, cool. So I just switched the clock signal, and now we can see here the counting. That looks good. We can adjust the speed. Yeah, as my biggest struggle was actually the buffer overflow. So as you know, there's one of the challenges you have to do is like do the buffer overflow, kind of exploit by hand, and I had that. I started with that, and I thought I would be pretty straightforward, quick with that, and I did it, and it worked locally. I did it, and it worked locally. It was all fine, and then it just didn't work remotely, and then I wasted hours over hours, and then you have only a limited amount of resets, so you need to be really careful when you try it out on the remote service, and then it would crash, and then you would have to reset. So I spent so much time like redoing the whole exploit and trying to get that work, and I just couldn't get it work. And then at some point I told myself I really need to move on. If I waste more time here, it would be annoying. And that made me a bit stressed out because I thought that would be the easy points for me. That's why I wanted to start with that. And then it didn't work. And I kept revisiting it during the exam time. And in the end, I wasn't actually not able to solve it. Turns out that it had to do, I believe, with the network MTU size or your packet size or so. Other people had the same issues. And somehow, the network connection to your machine was different, to your test machine that you had, or locally on your machine where you were testing it, was obviously different into the network of the thing, and so there was a different behavior of it when you were going through the network, and so the way how I structured the exploit just didn't work over the network in the end. I believe that was the issue. I don't know. I actually applied for partner once I reached the goal, like almost a week ago or so, I guess. Maybe a bit. Yeah, not quite a week ago. I think I applied for partner, but it always takes like 1 to 2 weeks, they say. So I haven't heard back yet. I mean, I'm streaming and just chatting all the time. So, but I would hope that they would tell me like what the issue is. So far, when they decline people for partner, they generally give a reason kind of for why. And so I would hope that they then provide some feedback for why they decided against it. Thanks for the heads up on the Typhoon challenge, Brimco. Awesome. I'm glad that you tried out. I hope you can solve it. That would be awesome. I like YouTube too. If I would not make YouTube videos, I don't know. I think Twitch is just a better streaming community, and I don't want to spam people with live overflow YouTube streams every day with doing this. I personally like the streaming community around Twitch. And for me, it's also just like a different platform from YouTube, because I am already on YouTube with videos, and so if I do wanna, I'm kind of experimenting right now, right? If this could be actually my income, or at least a part-time job or so, doing this YouTube stuff. And with YouTube stuff, I mean everything around that as well. And so for me, then it becomes a risk to have everything on one platform, and so to be able to branch out and build an audience on multiple platforms is probably important. You mod a lot of Twitch channels. Ooh, you're a mod on Twitch channel. Are you a Pokemon mod? You found 3 unexploited. Oh, it's an exploitation challenge actually? I thought it was maybe a reversing or something. I don't actually know what the challenge is about. I only saw that it's like an EXE. I didn't look at it. You are Summit 1G mod though? Nice one. Fist bump. Are you joking about Twitch TOS in regards to just chatting and science and tech? I wasn't. Yeah, of course, it was just a joke. Because people keep asking about why I'm not streaming in science and technology, and I personally chose just chatting. For now, I might experiment. I want to experiment maybe a little bit with the different ones, but for now, I want to collect a bit more data on being in just chatting, and then maybe I stream for a while in science and technology to test it out. But I think, categories are where people click on a category and check it out. And all the people that click on science and technology, first of all, they need to know that this obscure small category exists. It's not like one of the main big categories. So first I need to know, and then they are most likely already developers or so. They are already interested in tech, and they click specifically on there and go there. So my hope is, by streaming and just chatting, I know I'm too small. Just chatting is massive, so I'm like super far down. But still, I would hope that maybe once in a while, a person who has no damn clue what's going on just stumbles into this stream, sees some nerdy stuff, and maybe stays around, and then thinks, oh, hey, this is actually pretty cool, I want to check it out, and get them kind of like motivated to do this kind of stuff. You reversed it to get a better understanding, but empty input is supposed to crash it, but wasn't talking about those. I can't really say too much, as 2 more winners are to be found. Oh, wait. Is there already a winner for the challenge? Oh, you solved it already? Wait, I'm confused. You solved it already? That's awesome. Congrats. I'm so happy. Nice. Did they tweet about it or so already, or did you just like send it in, or when did you solve it? Oh yeah, 4 hours ago. Our first successful submission for TyphoonCon has been submitted. When do you normally stream? I just watched your last YouTube and clicked on the Twitch link to see when you were on next. Oh, that's awesome. I don't have a schedule right now. I almost stream daily. Basically stream daily. It varies completely. There's a website called Sully Twitch. Here, let me show you. So I don't have a schedule, and I might actually slow down. I will not be able to keep up daily streaming. It's impossible. Calendar. Oh, calendar, was it that? Oh, there we go. And you can see it varies from 12 p.m., 12 p.m., 5 p.m., 5 p.m., 1 p.m., 7 p.m., 6 p.m., 2 p.m., 5 p.m., 4 p.m., 2 a.m., 7 p.m., 7 p.m., 7 p.m., 10 p.m., 5 p.m., 3 p.m. Yeah, so it varies a lot. Turn on the notification, follow on Twitch, and then you will get a notification, I guess. Or go to Notify Me and sign up on Notify Me to get notified to whenever I do stuff. I have 11 subscribers. So yeah, Notify Me is a platform another streamer is building on stream. So it's a platform that unifies the notifications for your content creators or so. So you can subscribe with on Notify Me, and then you get notifications for when I upload, when I stream, and all these different things. And he's working right now, I believe, on the mobile app for Notify Me. I think that's currently what he's working on stream. So it's pretty cool. So the next video is designing a 7-segment hex decoder. Does everybody know what a 7-segment display is?
So let's take a look at how these display modules work. So you can see there's some pins on the back.
This guy kind of sounds like Murmus. I can see it, yeah. I think it's still very different, but they kind of have the same kind of like very, 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 what's it called, melodic talking in a similar way.
It's going to be, fairly complex. And so just to demonstrate that, of course, I built the thing.
Nice.
And this is what it looks like.
Nice.
And you can see there's an awful lot going on here. And it's because we've got 4.
It's not
5,
unnecessary.
6, 7.
It's not more unnecessary than our the whole computer that we are building. I appreciate this. I think this is cool. This looks really cool, don't you think? This by itself could be a thing that you can hang on the wall.
You'd have 8 bits of input and 21 bits of output for the 7 segments times 3 displays.
I feel so insulted that he wants to display 8 bits in decimal with 3 7-segment displays. This feels so wrong. I haven't really thought about it, but I guess he also implements that in that way for the computer. This sounds terrible. I want to see if we can make it 2-digit hexadecimal. I don't know how he will implement it. We will see that, but if possible, I want to immediately change this to something sane and to use have a hexadecimal output. Who would even want decimal output?
For whatever input we give it.
Mathematicians don't even
output,
use numbers.
And the output is just a function of the inputs.
Base 64 display? No, not a base 64 display. For base 64, you would need all the letters of the alphabet in upper and lowercase. What is an ESP8266? Is that not a microprocessor, or what is that? ESP? Yeah, that's a full microprocessor. Nobody would use that. No, I thought I remembered that it's a microprocessor. I was not, because you used it in combination with like as a solution for this 7-segment display as like an alternative to EEPROM. So I was wondering who would recommend a microprocessor. That's not an alternative. So I don't know. I thought maybe there's a more fancy lookup table chip or something that, I don't know. This video is 25 minutes long and we are 3 hours into the stream. I guess we have to watch it at some point. I guess let's start watching and get it over with.
Kinds of ROM chips or read-only memories And
Lean back,
ROM could
people.
refer to a chip
Lean back.
that has some
We are
data
in for a
it that you
ride.
can only read, and there's no way to write it or change it. So the chip is manufactured in a way that it has that data in it. Programmable read-only memory, which is what these guys.
I usually refuse to watch stuff at 1.5 speed because I like the voice of Ben. You know, I want to listen to his real voice and not a sped up voice. But why even watch this in such low quality? But maybe that's the kind of video for 1. Let's be a bit more sane and do 1.25.
Which allows you to program them, and then of course they act as a normal read-only memory at that point. But then you can also erase them.
Oh no, this is too irritating. I can't do it. Blasphemy.
Them electronically without pin 10 to the next.
So he's using here this AT28C16. So that's the 16X. But I bought other ones. So I wonder if later in his build, or are they compatible? Like, are they in that sense? Like, does it really matter? He used the 16K. Why did I buy? Because I have here. So in my package here, I bought these here. Why did I buy these? The 27C1M and the 28C64K. Look at that massive one. I think that's the 1M. You know, while the other small ICs kind of feel like plastic, these EEPROMs, they feel more like metal sheets almost. They even make like metal-y sounds. So this is all 64. Did I buy the wrong one, or are they compatible? I want to look at the data sheet in a second and compare those two data sheets. Ceramic. Oh, that's ceramic. Yeah, that makes sense. Are all ICs always ceramic? I don't even know. AT, by the way, stands for Atmega. So just by seeing that the chip starts with AT, the chip number starts with AT, you know, not Atmega, Atmel. Okay, so what's the difference between... So I have this one here, blah, 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 blah. 16K memory, organized as 2000 words by 8 bits. And so this here is, this has a lot longer description, is organized as 8000 words by 8 bits. I don't even really understand how that works. Like, these words by 8 bits, I don't even know what that means. Okay, so the pin out, so, it's a bit larger. The 16-bit has 8-bit address input, address A, so A is address, in, and then it has, oh no, there's also A8 and A9 and A10. Wait, so can this do, isn't that the address? So isn't on those the bits? A word is a unit of data. Yeah, I understand, but look at the output. It doesn't, there are clear, if it's like, you know, if it's like 2000 words by 8 bits. Oh wait, I misread this. I thought it's like a word is 2000. Okay, so to have 2008 bits. So 64. Okay, so it shouldn't matter. It's just a bit larger, I guess. It should then have more. It has 8K, so it should have 2 bits more address input, right? So this one has up to A13. So the other one is A11 and this one has A13. All right, so it just has two more bits. So we just need to be careful with the hooking up, but should still be fine. Why did I buy this one? I have absolutely no clue. And then we have the I/O is always output. So we have this many bits as address. I think Ben uses 2 of these chips. Maybe you can. Does he use 2 of these chips just for this decoder? Because I believe he uses 2 because he also uses that for the instruction register. But maybe the reason why I went larger is because you would need that too if you increase, because he uses that as microcode, and I believe there's no need to use 2 as you only need 7-bit output. Yeah, okay, yeah, but makes sense. We understood that now. Okay, so we just waste, I guess he uses 2 for the microcode because he needs 16 output pins. I guess I was stupid because we might want to use more output pins, 16-bit, because maybe we want to add more features like multiple registers or so. And then we would even need 1 more. But obviously we don't need, I don't know. A 16-bit chip would be better. Yeah, but do you have 16-bit output bits? That seems quite extreme. But I should check. I should actually check, because if we find that, that would be kind of nice. Oh, is the one meg? Oh, you are right. Let's check that. If that is also 8-bit. If that's 16-bit, maybe that's cool. I believe it might actually be 16, because it has like a 16 in the name. 5PU. Okay, so it's this one here. Oh yeah, that is 16-bit. So we could use that one instead of 2 EEPROMs, I guess. The 16 output lines in the CPU module are the control lines for all the other modules. Yeah, I know that. So the more modules you have, the more output lines you need. Yes, exactly. That's what why I was talking about it. This one is one-time programmable. Is it not an erasable? One-time programmable read-only. Uh-oh. Are these all one-time programmable? This is not an EEPROM. Oh, it's just an EEPROM. Oh, erasable. Stay away from OTP. Oh, now I get what you say with OTP, one-time programmable. Yeah, I mean, of course, I would want to stay away from OTP. Now, lessons learned. Okay, what a waste. I don't want to look up how expensive these were. They were probably a couple of euros each. I'm an idiot. Maybe I do another order. I will check if I can find an erasable like an erasable version of this one here.
Then IO3, I'll connect over here to the other side of these LEDs.
I guess I bought these 1 meg 16-bit for reason that then I have more bits in one package rather than having to use single packages for each.
And real quick, we can just check all the other numbers just to make sure. 0, 1, 2, 3.
I really love
4.
Ben Eater and the videos, but some videos are just drawn out unnecessarily. Like this 25-minute video could have easily been a 5-minute video. Maybe 10 if you want to include some more of the lessons learned and a bit more details. But that is just drawn out way too long.
4, 5, 6, 7, 8, 9, A.
Speeding up is
and
legal.
F. There we go. So, not super fun to program it using little jumper wires like this of our computer. So the previous,
especially given that all this would be rewritten with an Arduino program. Well, I do appreciate the by hand thing. I think for an educational video purpose, showcasing this, doing this by hand, and developing this, like, starting with the logic gates yourself, then introducing the EEPROM, then doing this by hand, and then leading to the programmer. I think that is awesome. Like, in principle, I love the idea. I would have liked to come up with this idea myself, and that is how I would have loved to do a video as well. I think that those steps are great, and showcasing that as well. You just don't need to show programming every single line. You don't need to show every single truth table output. You get the point with the first one. But yeah, I mean, complaining on high levels here doesn't matter. Cool. Okay, so we got that. Now let me think. Yeah, I think with this video is an hour long. I mean, this will be drawn out Arduino programming for sure. He might have to introduce how an Arduino works and stuff for really basics. But so I guess this is something we should do get into next stream then. I think it does help a bit. Anyone wanting to not see can skip it. Yeah, that's an argument for sure. I mean, the view numbers and the success of the series speaks for itself. It doesn't matter. I personally think it's a bit too drawn out. There's a reason why I try to squish my videos down into shorter times, because I feel like it's a bit unnecessary, but whatever, doesn't matter. In the end, it's Ether is every minute worth, for sure, absolutely. This is not, my criticism here is not a thing like I don't like it because of that. It's just a very small thing that I feel like could make the video better, but the video in itself is already great, Never forget, we can now write in C, and the first computer was probably written in a similar way. Yeah, that's the amazing thing, right? If you think about how we bootstrapped our whole technology, our whole computer stack, just think about this, right? When we now develop a new machine, we design the new PCBs, the new programs, and all the stuff is written on hardware that we already have. we use Linux machines now with design suites to design the hardware and manufacture the next hardware, and we program the firmwares and the kernel for new devices on machines that we currently have. And if you go back this evolution, there was a point where there was no software, and so we bootstrapped from some time, like programming something by hand, into something that could help us program a new machine, and then we slowly bootstrapped our way up. Isn't that insane and amazing? I wonder, does anybody know, has anybody ever seen somebody tracking this historically? I would be really curious. We all know these kind of hierarchy graphs of, what architecture came from what, but that's not what I mean. What I want to know is, because nowadays you might use now a Linux machine to develop the newest, I don't know, you use your x86 Linux to program the firmware of some ARM chip or so, you know what I mean? So nowadays it's kind of less interesting, but back then, what was kind of the first machine that was used to implement and develop the next generation of a new device, that kind of thing? Wouldn't that be amazing? Also the old IBM machines, like the IBM machines before there really were electrical computers, or like very they were not electronics, they were like electric, to like an archive or like a IBM museum kind of thing, where they have shown us these original, and this was fascinating. Let's see if I can find like a picture of those things. There was like one of the early machines that they used for the census, to like count how many people are where, and how they did that, with these machines. It's insane what they built. I wonder if this history contains the history of the Nazis. Let's see, their Nazi affiliation. Oh, what a surprise! Their own official IBM history doesn't contain anything about Nazi. Let's see, Germany. They leave that out quite conveniently. Company propaganda. But yeah, these old machines were pretty amazing. Is GCC built with GCC? Yeah, and this is like how you bootstrap the compiler, basically. I guess that's my question. That's kind of the thing that I find fascinating. There's actually also Turing's Cathedral. Jenny, thank you. I will check it out. I haven't heard about this before. I will check. I will probably watch it afterwards. There's there's a very famous paper. Reflections on Trusting Trust. This, Ken Thompson, Reflecting. I can really recommend you read this. It's kind of like so let's read the abstract. Maybe that tells us already what it is. Co-author of Unix recounted a story of how he created a version of the C compiler that, when presented with the source code for the login program, would automatically compile in a backdoor to allow him entry to the system. This is only half the story though. In order to hide his Trojan horse, Ken also added to this version of CC, that's the C compiler, the ability to recognize if it was recompiling itself to make sure that the newly compiled compiler contained both the login backdoor and the code to insert both Trojans into a newly compiled C compiler. In this way, the source code for the C compiler would never show that the Trojan exists. Wrap your head around that. Think about that. So let me recount that with my own words. So he had this idea. I'm not sure if he had this idea. I guess he had this idea. At least he wrote this paper about this. He implements a backdoor in the C compiler. So he writes his own C. So he modifies the compiler. And he has basically two if switches in there. The first if checks if you compile the login program, and then you insert a backdoor for that login program. And then the second if switch basically he made, if you compile the compiler itself, you insert exactly the assembly code to create that login backdoor again, and the compiler backdoor as well. So in his original, he has the original source code, the C code basically, that contains the code for the login backdoor and the code for backdooring a new compiler build as well. And so once he compiles a compiler with this backdoored compiler, this new compiler is clean code. But during the compilation step, it inserts the assembly instructions to backdoor login and backdoor a new compiler. And now he has crafted a compiler binary that will insert backdoors into a new compiler that is being compiled and into the login program. And so now if anybody else tries to compile a new compiler from that backdoored binary, his code is clean, the code is clean, but the resulting binary will contain again the replicating backdoor. And then somebody else wants to improve the compiler, implements new stuff, and then compiles this new compiler again, and that inserts again the backdoor. And so this means the backdoor is never present from that point on in the source code. The source code is always backdoor free. But the binary during this compilation step, the assembly, in assembly, there will be the backdoor. So you will never be able to detect that backdoor from the C code itself, because the backdoor is always only inserted in the binary. And that is a kind of interesting thought experiment, because now you can think back, how can you trust your compiler? Because if you trust your compiler, and then you think, oh, I just recompile my own compiler and now it's safe. But the compiler that you use to compile could already be backdoored. And so it creates, in a compiler is very complex software, so it's not easily reverse engineered and verified that it doesn't compile a backdoor. So, you can kind of use this kind of as a thought experiment on the reflections on trusting the trusted source of the compiler. I don't know, it's one of the papers that we had to read in university and then discuss about this. Isn't there already many compiler attacks before? Yeah, but you have to think about this is like from 1984. So, okay, this paper is older than I'm old. This is like early days of Unix and, early days of C compilers and so forth. This is obviously pretty, look at these images here of how this backdoor is implemented. You can read the paper. He explains exactly how he actually, implements that. Let's maybe read the moral really quick. It's not a long paper. I really encourage you to read it. The moral is obvious. You can't trust code that you did not totally create yourself, especially code from companies that employ people like me. No amount of source level verification or scrutiny will protect you from using untrusted code. In demonstrating this possibility of this kind of attack, I picked on the C compiler. I could have picked any program handling program such as an assembler or loader or even hardware microcode. As the level of program gets lower, these bugs will be harder and harder to detect. A well-installed microcode bug will be most impossible to detect. After trying to convince you that I cannot be trusted, I wish you to moralize. I would like to criticize the press in its handling of these hackers, the 414 gang, the Dalton gang, etc. The acts performed by these kids are vandalism at best and I didn't even remember this punch against the old school hacker groups here. I didn't remember that. That's amazing. And best and probably trespass and theft at worst. It is only the inadequacy of the criminal code that saves the hackers from very serious persecution. The companies that are vulnerable to this activity, and most large companies are very vulnerable, are pressing hard to update the criminal code. Unauthorized access to computer systems is already a serious crime in a few states and is currently being addressed in many more state legislatures as well as Congress. There is an explosive situation brewing. On the one hand, the press, television, and movies make heroes of vandals by calling them wizards. On the other hand, the acts performed by these kids will soon be punishable by years in prison. I've watched kids testifying before Congress. It is clear that they are completely unaware of the seriousness of their acts. There's obviously a cultural gap. The act of breaking into a computer system has to have the same social stigma as breaking into a neighbor's house. It should not matter that the neighbor's door is unlocked. The press must learn the misguided use of computers is no more amazing than drunk driving of an automobile. I don't remember this at all. That would have been such a cool addition to the story of Script Kiddies video. I need to remember that. Maybe I can incorporate it in some other thing. What do you think about the Intel management thing? I don't think anything about it. I barely know anything about it. Anybody talking about it probably don't know really anything about it. Maybe you can specify more what you mean about this. It's a very broad thing. It's like, what is your opinion about the sky? I don't know. I'm opinionless about the sky. It's a sky. Like, I don't know. You need to be more precise. There's a lot of backlash because it can't be removed or turned off without the CPU not working anymore, and you can basically control the whole computer. So, I don't know the problem. Like, the thing is, I understand. My criticism is that it's not fully kind of like explained. You know, it's a product that you buy that has features that are not well documented. That's my biggest issue, I guess, I have with that. But once it would be properly documented, I wouldn't have my problem is with lack of documentation because it gives us lack of understanding. But once we better would understand it, then, you know, I don't have any opinion about it. It's obviously a problem when unauthenticated people can somehow make use of it, but if it requires low-level hardware access already, or physical access, or internal network access, that seems to be very deep inside already. I don't really care about that. I have my issue about the kind of discussion about Intel ME is about what are the requirements for these exploits, and that's basically my whole point. What is the requirements of these exploits? Because, you know, exploitability and likelihood and risk comes with how exposed are you actually. Clearly, it's not like you can take over immediately the world, because this hasn't happened. And there's a lot of marketing going on. Like, the companies that do research into this obviously blow this up in media like hell and in their talks, and are very kind of like unclear about the requirements for the exploitability. There's sometimes like a network component, sometimes there's I don't understand, like, you know. So not only is Intel ME undocumented, the exploits about it are undocumented, and it's annoying the hell out of it. Why can nobody just say the requirements for exploitability are this feature has to be enabled, it's enabled on these CPUs, it's not enabled on this, it requires physical access, it requires code execution in ring 0, it requires a local network access. I don't understand why this is not properly defined what the attack surface is. Because clearly the attack surface is not huge, because clearly the stuff doesn't fall over immediately. I don't know. Yes, it's established that ME has network stack correctly, because it's like a management unit that you can remotely manage. But what does remotely manage mean? And, you know, I don't know. Like, so what? Network access is required for some exploits. Is the network access, does that work with any network card that you have in your machine, or only with the network port that is directly, you know, on your motherboard connected to your chip there? I don't know. Like, does it affect? I don't even know. You know, does it affect? And if you have a 10 gig Ethernet card in there, you know, is that like all the servers that are running that have special 1 gigabit, 10 gigabit, or even 100 gigabit Ethernet cards, are these machines still affected? Is that somehow still kind of bridged through motherboard chips plus generic driver ones? But you get the complexity, you know. This is like low-level hardware stuff, which with a lot of if cases in front of if it's exploitable. And I feel let down by the people that have, at least the research that I haven't fully studied it, obviously, but the research information and talks I've seen about this were all wishy-washy and weren't really precise on what it is, because they were fear-mongering, and generally I'm a bit always skeptical when they start like fear-mongering about vulnerabilities, because clearly the apocalypse hasn't happened. You know, the world, we have more issues with Eternal Blue than we have with the crazy Intel ME. And yeah, I do think it's a concern. It's a concern for the researchers and Intel, to concern about the research and Intel to make sure that this isn't crazily bad. It is a concern, but I don't think it's a concern for us general consumers. We shouldn't care about it. I saw a video about a chip that could replace a resistor and modify signals through it. Yeah, I know. Like, you can make hardware pretty small. Who cares? This is all theoretical attack surface. Like the trust and trust. It's like this paper here. It's good to mentally think about this. To understand on what kind of trust levels we are building upon. But and I love these thought experiments. But there's always this kind of hacking thought experiments always have to be faced with the reality of real risks, and there's way too much fear mongering happening. Sometimes I have a bit of a trouble to communicate this well because from my YouTube channel that I'm extremely passionate about the really obscure and esoteric hacks. I love these weird browser quirks and bugs that we are finding and making videos about. These are so awesome. There are so little hacks. There's so much ingenuity into these small parts. And I love that. I can, be ecstatic about this all day long. I love that. That's what my whole YouTube channel is about. But we also have to admit that realistically, the risk, doesn't really matter. Phishing is the biggest problem we have. Phishing is probably the largest hacking issue we have. If I would go about real world impact, I would talk about phishing all day. But I don't really care what the real world impact is. I care more about the technical ingenuities, right? But that also means we must not fearmonger, because fearmongering should happen about phishing, I guess, because this is what has actual impact. And then maybe once in a while some kind of crazy Eternal Blue exploit or so that actually has some real world effects. But all the other stuff is, chill down. Stop the fear-mongering in IT security. I hate it. Most end users don't need to care about this. Let's deal with that kind of stuff internally. But that obviously clashes with the wish for marketing and exposure for companies. I believe our move forward in the industry has to somewhat be the path that also science has done. We have thousands and thousands and thousands of scientists conducting research and investing their whole lives into research. But only a small part surfaces into real world products and commercially viable products for consumers. But as a society, we still understand that this investment, this whole bottom of the iceberg that you don't see in science, the research, is all important, because that all helps us to get to that, that one kind of fine thing that helps us, society, humanity, to move forward. And I think security will go there too. So basically, security like 10 years ago, or still kind of now, we are in this transition phase, I think now. Back then, security impacts, a single person can take down the whole internet or so, That's kind of like the physics, science, and chemistry of, 100 years ago, where a single person can have massive impacts on research of society. Nowadays, we transitioned in regular science away from that, and now science is done in the darks. The most people don't really have to care about this anymore, and once in a while we have some great findings, but we still invest into this huge hidden iceberg of research. And I believe we are in a transition area for IT security as well right now, and so we have some clashing interests there. I believe in the move forward, we have more and more security issues and findings that are irrelevant for the public. They don't care. They are not as impactful as we want them to be, but they are important steps forward to still build, IT security research and stuff like this. And once in a while, something will pop out there, but it will be more contained in our society community. But that clashes with the marketing wish and the publicity that our companies want. with fear mongering and stuff like this. And it gets more and more embarrassing. Like more and more fear mongering happens now with less and less impactful vulnerabilities, and it gets more and more embarrassing. And that's kind of an issue. That's why I believe we are in kind of a transition area, because we see more and more vulnerabilities hyped up where the impact is very little. That doesn't mean that I love them. I still love them. I still think they are great, but it should be something that internally, we discuss. Like Rowhammer, I think, is a good example. Rowhammer is such an amazing research finding. It's incredible. It's awesome. I love that Rowhammer, these hardware attacks, so much, and they are incredibly important as a foundation for our research. But the general public doesn't have to care. But I also think, for example, Rowhammer, they have done their marketing fine. They have written their papers. They have published their papers in scientific journals. They talked about at conferences about it. They do it correctly, but that's also because Rowhammer is coming out of academia already. These are people that have done that kind of research at universities. So they do it already. Then on top of that, you might have, news companies or other companies to piggyback on that research and then do a little bit of more fear mongering, some kind of marketing thing. But the research themselves, I think they have done it perfectly fine. I think that is a good example of how security research should look like. Spectre Meltdown, same thing. Great academic research. It was published as journals and papers, and made a website to explain it. Great way how to do it. And then journalists have piggybacked on top of it and have kind of blown it up a bit, but it doesn't really matter for the consumer, for most people. It matters a lot for our security research community. It matters a lot for the science behind it. It doesn't matter really for the consumer. Does that make sense? I don't know. I feel like that's a topic I kind of want to make a video at some point over. I just need to sort my thoughts a little bit more concisely and with some examples and stuff like this. That would be kind of amazing if SHA had a backdoor that has been undiscovered by, I guess, decades now of mathematicians trying to break it, and nobody has found it yet. That would be pretty impressive. But I think maybe you try to confuse it with elliptic curve cryptography. People say a lot of stuff. Ignore it. If you don't see a published math paper about a cryptography backdoor, you don't need to care about it. All of these doesn't matter after governments ban secure crypto. I just had this conversation recently with another person. Are you aware that cryptography is already heavily regulated? Because as you remember, cryptography was very important for wars, for encrypting communication. So you still have actually a lot of regulations about cryptography, especially in terms of export of cryptography from the United States. The export of cryptography technology and devices from the United States was severely restricted by US law until 1992, but was gradually erased until 2000. Some restrictions still remain. Regulations were introduced as part of munitions controls, which required license to export cryptographic methods and even their descriptions. Because it's kind of like a dual use thing, right? Cryptography was used a lot in war. So this knowledge, for exporting this kind of knowledge outside of a nation, is kind of a dual use thing. So there are regulations about if you're allowed to do this or not. Each country has their own kind of funny laws in that regard. For example, in Germany, we have a lot of, I really hate Wikipedia, where is this coming from? How is this politically loaded? What are you talking about? So for example, in Germany, we have export controls when it comes to exploits. Exploits or any kind of hacking tools are deemed dual use. You can use them for basically military, attacks or whatever. So if you want to sell an exploit to somebody, if I as a German want to sell an exploit to somebody, I would first have to register and report that I want to sell it, and to whom I want to sell it and what I want to sell it with the state. I need to ask the government if I'm allowed to sell it. This will then go through several points inside of the German government, basically different ministries, including, for example, our intelligence agency will have a look over the exploit I want to export. And without giving me any reason, any of these different parties that it will go through can decline my request for exporting that exploit. This creates, for example, problems with if you have an exploit and you want to present this at a conference. If you haven't published it before and you want to present that at the conference, what you are doing is you have a secret exploit knowledge. Like if you want to go and make a O-Day presentation at some conference in some other country, for example, go to the US or even go to somewhere in Asia to a Chinese conference or so, you have an O-Day that you want to present. I'm exporting it at this point. It's my knowledge. I travel into a different country, and then I present and then I release that knowledge about the exploit in a different country. That I'm exporting it at this point. I'm taking it out of Germany. I'm taking it out of Germany and travel into a different country with my laptop that has this exploit on it. And then once it's published, then that's export control. Yeah. What I'm saying is there are a lot of regulations about this kind of stuff. And even with cryptography, there are a couple of things. Wasn't there also this thing, PGP, publish, book, get around? Like, I obviously have absolutely no clue what I'm talking about. I'm not into policy. I'm not into law. I don't understand all these different things. All I'm just saying is there's a lot more regulations and laws that you may not be aware of that make things kind of crazy. Here, for example, apparently this is a thing. PGP released its source code as a book to get around US export laws. But yeah, what I'm saying is, like, especially with like the discussion in Australia right now with the cryptography things, I think some people kind of forget that the internet is full of regulations already. And especially in terms of exploits and cryptography, you quickly run into military regulations of kind of export things already. It's kind of really interesting. I mean, the thing is, these things also are not really applied. We have these export controls in Germany, but basically nobody cares about them. There's not a single case where it was enforced, court case or anything like that. But they could change from one day to another. It could be that Germany suddenly takes it super seriously. I've heard that, for example, in Israel, they also have export controls with exploits. And apparently they are a lot more stricter, but that's just what I heard. I don't know. Like, they take it really, really seriously, but I don't know. I don't have a source for that. That's just what somebody told me. So I, for example, also know that the Fraunhofer Institute, which is like a kind of an academic research institution in Germany that do also security research, that when they go present their findings at some conference outside of Germany, they go through the regulation steps. They always tell the government with what kind of devices they travel outside of Germany and what exactly is on those devices, and what they basically export and take out of Germany, because they are closer to the government, I guess, because of academia and being a research institution, getting a lot of money from the government and stuff like that. So I've talked to these researchers before, and they told me about that they do this every time. It sounds a good way for the government to take advantage of research of the private sector. I understand where you're coming from, but you just have to imagine this to be weapons. It's if you kind of tell yourself, okay, these exploits are kind of like weapons, and now think about the weapon industry, then this is heavily regulated. What kind of ammunition you are allowed to manufacture, to sell, and to export. That's the main debate. Is it a weapon or knowledge? Well, yeah, in the end, yes, we can kind of talk about this semantically. I don't know exactly how the legal argument goes. I'm just thinking, do you sell the weapons directly, or do you just sell the plans, the CNC data, how to mill some kind of gun? Is that not the same as the weapon? You know, I don't know. In the end, this, you know, there are laws, and the question is always, are they enforced? And then how are they enforced? They can always be interpreted in weird ways. The same law might be decided differently from one judge to the next judge. We simply don't know. We just know that these regulations and laws exist, and we know that they might be able to be interpreted in that way. We also know that they haven't been interpreted that way yet. But it's something to think about and something to pay attention to and something to see how it develops. And, you know, all of this is fluid. The government's changed. New laws are introduced. Old regulations fall away. It's constantly changing. It's just, I think it's just, I don't really know. I wasn't really affected by it yet. But I do think it's kind of interesting to kind of remind yourself of this complexity sometime. You know, I find it also silly to consider an exploit a weapon, or a dual-use export-controlled Vazinar kind of thing. You know, I find that silly myself too. But you also can understand that you could argue it in that way. You know, it's kind of like a thought experiment, a legal kind of philosophical debate at this point. Let's say they are weapons because they could theoretically disrupt important infrastructure of a country. Okay, if we define a weapon as something that can damage infrastructure and damage the you know, the infrastructure of a country or so, like a bomb would, then yes, some of these exploits might fall under that, and many don't. You know, a WordPress exploit is definitely not important for national security, but I don't know, like if there's a crazy Intel ME backdoor, that maybe might be important. I don't know. I know that Ben is using the EEPROM for this use of microcode. It's a big lookup table. I understand. It was just, we talked about, didn't we talk? Oh no, maybe you weren't there earlier. I don't know. We talked about this extensively. I think a multiplex is just a grid of wires. Yeah. So how does this part number thing work? Why was this one non-erasable? So these are all EEPROMs. Okay, so I guess one of these numbers here is probably that it's an EEPROM. Maybe it's the 27. That maybe 28s are like EEPROMs. Okay, that doesn't exist. Is that the one that Ben Eder is using? I mean, I might buy that anyway. 28C16. 28C, yeah, okay. Wait, this is 8K at 8-bit. Let's see this is exactly the one I have. This is the one that I bought. It's that's the one I bought. I guess Mauser doesn't maybe have the C16. Is that the reason why I didn't buy that one? That might be the reason why I didn't buy it, I guess. Okay, so that might explain why I didn't buy that one, because I looked in for an alternative, I guess. Wait, this is a wrong image, isn't it? This doesn't make any sense. This is a wrong image, right? One wire EEPROM. I'm so confused. Wow, this exists? What? That's a thing? Oh, one wire as the protocol. Okay, that makes sense. I see, okay. And there are serial EEPROMs. Yeah, makes sense. Okay, yeah, that makes sense. One wire. What a crazy package. Interesting. You found several? Can you link me the search? I don't know that if that works, but can you link that? Okay, wait. Okay. See the package type? This is like some fancy interface stuff. That's like some kind of protocol. Like we couldn't implement this kind of logic. You know, you need a clock to clock in the data and clock out the output. These are serial. Yeah, that's no use for us. You just joined. What's going on at the moment? We are just procrastinating the end of the stream. I will end it in a few moments. We built the program counter today. Oh, I guess I could also run it again. It shows a 0 current draw right now. Oh, there we go. It was somehow not fully plugged in. Wow, this circuit right now draws 1 ampere. In last time you checked, we were building the RAM. I mean, this is the RAM here. This is the RAM. These two are the RAM control things. And then we built the instruction register down here. And then we built the program counter up here. So it's not a lot, like in terms of wires compared to the RAM. I mean, the RAM was a massive thing. You could go over what you built, would be ready for the YouTube montage. Yeah, shall we capture some? You are right. I need some thumbnail pictures. So here, let's remove my face. The program counter. Bam. YouTube thumbnail right there. Next YouTube thumbnail that we need is a reaction picture. Do you think that will do? You think that will be good? I need to hold something with a question mark. Like, I need to do like... All you need is the doggo in the background. Hey doggo, can I abuse you for a thumbnail? I woke him up. Now he looks mad at me. What is happening here? We are making clickbait thumbnails for the next YouTube video. Hold EEPROM instead of EEPROM. This could also be a cool thumbnail. What do you think? Come on, autofocus. Don't disappoint me. The face tracking is just too good. I found what in my closet? 8 things and wait till you see number 4. There you go. Why this smaller chip is better than the bigger chip. Chips, you can dip them. Well done. Good job. I like that. Haven't heard that one yet. Would have been faster doing it by hand, what I wanted to show you. I need to speed that up. I need to figure out why this is so slow. Wow, I started this an hour ago, this process. This is way too slow. Holy... I really want to stop streaming. It's just such a waste of my time right now. Okay, you know what? I will kind of fake this. 1 second. It's good enough, I believe. Just change one thing here. Believe now it should work. Okay, so let me try. So let me see if this works. Are you ready? Are you ready? This is what we have waited for an hour. Please don't break. Please don't break. It seems to work. Okay, thanks. See you all. Bye bye.